Hey guys, today we're going to talk about a number of things, but the first thing is on multiplying polynomials. So we've just finished discussing different types of polynomials. So hopefully you remember a binomial, a monomial. Those are the ways that we can classify polynomials according to their number of terms. All right, so let's start by looking at something that we looked at in class just last time. And there was a little bit of confusion about it, so hopefully our conversation then has helped clear stuff up. But let's just start out by looking at something like this. So again, we've done distributive property for a while now. We did that for the first time last year. But the difference is that usually this was a number outside. So now that we're talking about polynomials, we're going to start having things out here that are not just numbers. They're going to be variables or possibly numbers and variables. So what I would say is that this is now taking a monomial and multiplying it into a binomial. Or maybe you could say multiplying a binomial by a monomial. All right, so we're going to use the distributive property, and we're going to multiply each of these terms by this thing out front, this monomial out front. And so as we discussed in class, but let's just say it again, we're going to take this 6n and we're going to multiply it by that n that was out front. All right, so here is the first term of the binomial, and this is the monomial that we're distributing. Then there's an addition sign in here, so we're going to put a plus, just like we do when we distribute numbers. And then we're going to take the 7 and multiply it by the n. All right, now we're just going to clean things up right here. So again, we mentioned how we don't give the n to each of these things. We don't multiply the n by the 6 and the n by the n. We give it once to this term. And then once we give it once to this term, we decide whether we want to multiply it by the 6 or by the n. And generally we choose the one that it is most like, if there is something in there that it's alike. And so here we're going to choose to multiply the two n's together. Now this is going to go back to the exponent rules that we just finished talking about. These are like bases, the n and the n, that are being multiplied together, and so the product rule says that we add the exponents together. So when we simplify this, we're going to get 6n squared. And then we can't really do anything to this because they're not alike, they're not like bases, and so we would just say this is plus 7n. Okay, let's do another one. Let's say we have 8r times 12 minus 5r. So again, I have a binomial right here, two terms that's being multiplied by a monomial, one term, and I'm going to distribute it into here. All right, so this is going to say take the 12 that's in there and multiply it by the 8r. And then because this is a minus sign, I'm going to put a minus right here. And then I'm going to do the 5r that's in there times the 8r that was out front. All right, now when I simplify this, I choose which things I'm going to multiply together. Because these are both numbers, I'm going to choose to multiply them together. So 8 times 12 is going to give me 96, and then times that r. There's nothing I can multiply that by because there's neither the 12 nor the 8 is like that. Then in here I'm going to have the minus. Now again, multiplication is commutative, so I can write this as 5. Again, remember these are multiplied together, and this, we're specific about that being multiplied because we're taking these two things and multiplying them. I'm going to switch the order of these two. I'm going to reverse them. So it's 5 times 8 times r times r. When I do that, this is going to give me 40. And r times r, just like in the previous example, these are like bases. They're both r's. They're being multiplied, and their exponents are both 1. So I add the exponents, and I get r squared. All right, so I would get 96r minus 40r squared. Let's do another example here. Let's say I've got negative 3v squared times 6v minus 11. All right, so again, I've got a number and a variable. The number part, the coefficient right here, is negative, And our v isn't just v to the first like it was in the previous example or the previous two examples, it's v to the second power. All right, so let's distribute that again. All right, so I'm going to take the 6v that was in there and I'm going to multiply it by negative 3v squared. Now, I have a minus sign here and I'm multiplying it by negative. So I'm just going to write this as minus 11 times negative 3v squared. But we're going to pay special attention to that when we do this negative sign and a minus right here. All right, so let's take a look at this first. Again, I'm going to rearrange the terms because they're all being multiplied together. Again, that's not a minus, that's a negative sign. So I have 6 times negative 3 times v squared. All right, 6 times negative 3, negative 18. V times v squared, again, I have like bases that are being multiplied together, so I'm going to use the product rule, which says add the exponents. So this is going to become v cubed. All right, I'm still going to have the minus in here. Now, again, I've got 11 times negative 3 times the v squared. I'm going to just separate them so that you just see the two number parts here. 11 times negative 3 is negative 33. And then I've got a v squared. Now, if I use keep, change for this, when I've got a subtraction sign, what comes after it, I change it to the opposite. So this is negative 18v cubed minus a negative becomes plus a positive. So this becomes plus 33v squared. All right, now you might be asking, do I have to write all those steps in here? Generally, I don't. At this point, when I see, at the beginning, when I see a negative here and a minus, I know that when I do a negative times a negative, I get a positive. And so generally, I skip this step right here of writing it minus a negative, and I just write it as plus. So again, that comes because we did a minus. Really, we can think of this, I'm sorry, we do a negative times a negative. Instead of thinking of this as a minus, we can think of it as a negative sign. So negative 3v squared times negative 11 will give us that positive 33 that we got right here. Okay, so I'm going to ask you to pause because I want you to turn to page 101 in your workbook, and I would like you to do numbers 1 through 4. Okay. So hopefully you didn't have too much trouble with those, or you got your questions answered. All right, so then next what we're going to look at is not a monomial times a binomial, but now we're going to do a binomial times a binomial. All right, so before we would have had something like this where we would have just distributed that 5 through a monomial times a binomial. Now we're putting a second term in here. All right, so just all you need to know here, it's only slightly harder, it's a few more steps, but what we need to do is make sure that each term in our first binomial gets multiplied by each term in the second binomial. All right, so first we're going to multiply the 3x by each of these two terms, and then after we're done that, we're going to make sure that we multiply the 5 by each of these two terms. All right, so we're just making sure that this guy gets a chance with both terms here, and this guy gets a chance with both terms here. All right, so let's first look at this. The 3x gets paired up with the 2x. So 3x times 2x. All right, then we're going to do minus because of that, and then 3x times 7. Again, maybe you're noticing that I'm putting them in the opposite order that I did up here in these original problems. It doesn't matter which order you do it in. So because multiplication is commutative. So if you want to do 2x times 3x, that's fine. And then 7 times 3x, that's fine. Okay, so this guy, the 3x, has had a turn with both the 2x from here and then negative 7x. I just put the negative right there. Okay, now we're going to let the 5 have a turn. So it's going to be, because 5 is positive, we're going to write plus, and then it's going to be 5 times 2x. And then it's going to be a positive 5 times a negative 7, so it's going to give us a negative 35. I'll just write plus 5 times negative 7. All right, so the positive 5 times the negative 7 right there. Okay, let's go through and clean this up. So hopefully you're getting to the point where you don't need to rearrange things. All right, but if you still do, you can just flip the terms here or flip the pieces so that this is 3 times 2 times x, which is going to give us 6x squared. Minus, again, if we flipped it, we would write 3 times 7 times x, which gives us 21x, plus 5 times 2 is 10x, and then 5 times negative 7 is negative 35. So again, you could either write it as plus a negative 35, but really we would just write it as minus 35. Now, these types of problems have one additional step in them, and that is that we have to combine any like terms. All right, so I'm looking at this and I see I have a negative 21x and I have a positive 10x that we're going to combine. And they're like terms because they both have exactly the same variable with exactly the same exponent. Notice this is not a like term because while it has the same variable, it has a different exponent. All right, so I'm going to leave this 6x squared alone. Now negative 21x and positive 10x, because the signs are different, we take the difference. So 21 minus 10 is 11, and then we take the sign of the larger. So this is going to be negative 11x minus 35. And that would be our final answer. Okay, the next one is 7z minus 6 times 4z minus 1. So again, everybody gets a turn. So 7z gets a turn with 4z, 7z gets a turn with the minus 1, negative 6 gets a turn with the 4z, and negative 6 gets a turn with the negative 1. So what this is going to look like is 7z times 4z, and then 7z, I'll put a minus sign here, so then 7z times the 1. Again, you could also think of this as plus 7z times negative 1. It'll work out the same, so whichever is easiest for you. I'll just write it like this. And then the next one is we need the negative 6 or the minus 6 times 4z. Don't forget to put a dot in there, otherwise it looks like 64. And then minus 6 times the negative 1. All right, so let's go through here. I'm not going to switch the terms this time, or the order of things. I'm just going to say 7 times 4 is 28, and z times z is z squared. And then minus 7z, because 7z times 1 is 7z. Again, if you had chosen to write it as plus 7z times negative 1, we would still end up with negative 7z, which is what this is. All right, then we've got minus 24z, and then plus 6. Okay, let's combine like terms. So we just have these two in here. So we've got a negative 7z and a negative 24z. So because the signs are the same, we find the sum. So 24 and 7 would be 31. So let's see, we've got 28z squared minus 31z plus 6. Final answer. Again, don't try and combine these two because they're not like terms. Okay, let's do another one. I hope that I'm not going to run out of time here and it's going to shut off on me. All right, 9y squared plus 2 times 8y minus 5. All right, notice again, it's still binomial times binomial, but here this one has a squared on it just to see what would happen here. So everybody's going to get a chance. The 9y squared is going to get a chance with both these guys, and the 2 is going to get a chance with both these guys. So 9y squared times 8y, and then let's do it the other way, this way that we didn't do last time. 9y squared times negative 5. Again, I'm saying negative 5 because that is a negative 5 or minus 5. All right, then plus 2 times 8y, and then plus 2 times negative 5. All right, Again, 9 times 8 is 72. Now we've got a y squared times y to the first. Again, it's just an implied one. Product rule says add the exponents. Then we've got a positive 9 times a negative 5, which gives us a negative 45 or minus 45 y squared. 2 times 8 gives us 16 y. And then 2 times negative 5 is minus 10. Now, again, we would go through and we would see, can we combine any like terms? But as we look here, we've got a y cubed, a y squared, a y, and something that has no variable. So none of them can be combined. This doesn't have any variable at all, and none of these have the same exponent. So that is our final answer. Okay. Let's do one more. Okay, suppose I gave you that, right? The first thing that you should do, again, the temptation is to say, now that you know the power rule, to distribute that through, but don't do that, because remember, the product rule has to just be a monomial in there. If we had, you know, like 3RZ, we could distribute that. But in all of the problems that we did with power rule, we never had a plus sign in here. So please don't do that. You will definitely at some point do that, I promise you, but really try to resist. What you need to remember is what this means is 3r plus 1 times 3r plus 1. And now we're just going to go through and we're going to do it like this. All right, 3r times 3r plus 3r times 1. I'm just going to write 3r. And then we'll do that again because 1 is going to multiply by this 3r, so that's also going to give us another 3r. And then plus 1 times 1, which is 1. All right, now let's clean things up. 3r times 3r is 9r squared. And then 3r plus 3r is 6r plus 1. Final answer. Now let me just, before I stop this video and start a new one, let me just go back here, because when you read the section in Fred on this, he calls this, think of it as like a dance, and these are the boys and these are the girls, and all of the boys want to meet all of the girls. So again, this idea that we've been talking about everybody getting a turn with the other group right there. So that is one way you can think of it. There's also another mnemonic that you can use called FOIL, which you'll see in a lot of other books, but Fred never calls it that. What this stands for is multiply the first term in each parenthesis. So we did the 3x times the 2x, the first terms. And then this stands for outer. So you would do the ones that are on the farthest edges, the outside ones. So that was the 3x times the 7, or the negative 7. This stands for inner. So that was the 5 times the 2x. Whoops, inner. And then L stands for last. All right? And so that would be the last term in this parentheses times the last term in this parentheses. So if you remember FOIL, you'll just remember do the first one in each parentheses, do the outer ones, do the inner ones, do the last ones. I like it because it's a mnemonic, but honestly, in our next video, we're going to talk about multiplying a trinomial and a binomial together, and there is no mnemonic for that. So I feel like it's just more helpful to remember. You just always have to make sure that each term gets a chance with every other term in the other parentheses. And if you can remember that, you could multiply a 4-term polynomial times a 5-term polynomial. You just have to remember to always match up each pair. So again, remember, you'll hear FOIL a lot as you're reading different things, but again, not in Fred, anywhere else you see them. Okay, we'll be back in just a second, but you are going to pause because you are going to do problems on page 101 through 102. You're going to do 6, 7, and 13. Okay, so pause the video and then I will see you again momentarily. Okay, let's look at our last example in here, because I told you that we were going to do a trinomial. So 2x squared plus 6x plus 3 times a binomial, 5x minus 2. Right. On this, on page 102, there are examples of trinomials times trinomials, but we'll wait until we feel a little bit more comfortable before we move on to those. So again, the idea is that everybody in this, every term in this first polynomial, this trinomial, gets a chance with everybody in this one, right? So the 2x squared is going to get multiplied by the 5x, and it's going to get multiplied by the negative 2. The 6x is going to get multiplied by the 5x and multiplied by the negative 2. And then again, the 3 and the 5x are going to get a turn, and the 3 and the negative 2 are going to get a turn together. All right, so let's go through and do that. So we've got 2x squared times the 5x in the second parentheses. So 2x squared has had a chance with the first one, now it has a chance with the second one. So then it's going to be plus 2x squared times negative 2. All right, first one times the second one. Then we move on to this 6x. 6x wants a turn with the 5x, so plus 6x times 5x, and it's going to want to turn with the negative 2. I'm going to run out of space here, so I'm going to move down to another line here. So then 6x times negative 2. And then the 3 wants a turn, so it's going to be 3 times 5x plus 3 times negative 2. All right, so you can see how this 2x, right here, let's do a double underline here, gets a chance with this guy and this guy. The 6x gets a turn with the 5x and the negative 2. And then the 3 gets a turn with each of them too. Okay, let's clean up. So now we've got 2x squared times 5x. Again, the 2 times the 5 is going to give us a 10. And the x squared times x, remember product rule, like bases, you add the exponents. So this is x cubed. Next term, it's going to be 2 times negative 2, which is going to give us negative 4. And then the x squared. Again, that negative sign here becomes the subtraction, because we could either write it as minus or plus a negative. The minus is just cleaner, so we're going to write it like that. All right, the next term, we've got 6 times 5 is 30, and x times x is x squared. Okay, then we get to this next one. That's going to give us 6 times negative 2, which is negative 12 or minus 12, and then the x. Then we have 3 times 5, which is 15, x. And then 3 times negative 2, which is negative 6. Now, we're going to go through and we're going to see if we can find any like terms. All right, so hopefully you can spot that these two right here are like terms because they both have an x squared in them. And these two are like terms because they both have an x. So we'll leave the 10x cubed alone. All right, so think about what you would get here. Hopefully you said 26x squared. All right, do the same here. Hopefully you said it would be plus 3x. And then that minus 6 has nothing to combine with, so it would just be that. And that would be your final answer. Okay, so I want you to pause here and do page 102, number 21. Okay, that's it.